Good morning. This is the first notes in Unit 5, Introduction to Polynomial Functions. So part 1 is the degree of a polynomial function. So when we think of the general form of a polynomial, we think of this form here. All you need to know is that this form is there to accommodate polynomials that have degrees higher than 2. We learned about a polynomial last unit when we learned about quadratics, okay? And remember, our general form, or standard form of a quadratic was ax squared plus bx plus c. This form here is similar. Instead, it accounts for a degree higher than 2. So a to the n, so that could be like degree 3, okay? X to the n minus 1, so that'd be x squared. Continue on for how many ever exponents we have, and then x, and then our c value, that constant, a to the 0. Okay. When written in general form, the largest power of x is the degree. Okay, the largest power of x is the degree. So in the examples below, we have a cubic function, x cubed plus 2x minus 6, which means that the degree is 3. 3 because 3 is the highest exponent attached to the x. For the second one, we have y is equal to 4x cubed minus 6x to the 5th plus x squared plus x, which means this degree is 5 because our highest exponent that's attached to an x is a 5. And then for the last one, notice how this one is already in factored form. So in order to find the degree, we add the powers of each variable. So this one is 1, 2, 3 for a degree of 3. Okay, go ahead and pause this video and try 1 through 5 on your own. And when you're done, unpause it to see the answers. So for number 1, it says f of x is equal to x squared minus 4. So that means the square is our largest exponent. So that means we have a degree of 2. The next one, we have negative 3x to the 4th plus x, which means our exponent of 4 is our highest attached to the x. So our degree is 4. Next one, we have pi x to the 4th plus x to the 5th plus 11 minus 3.1x cubed. X to the 5th has the highest exponent, so this is our degree 5. The next one is factored, so we have to count all the individual x's. So we have 2 x's here, 3, 4, for a total degree of 4. And then on the last one, this one's a little tricky because what it wants you to do is pick the largest exponent, but what you're actually doing is picking the largest exponent attached to a variable. So the answer here would be 4, meaning our degree is 4. On this next part, we're going to practice multiplying the polynomials when they're written in, and we want to make sure they are written in general form. So right now they're in factored form. We have to write them in general form. So in number 6, we have 3 parentheses being multiplied. Okay. Our instinct should be to use the FOIL method. However, we can't use the FOIL method on 3 parentheses. So we're going to start with the first 2, FOIL them, and then whatever answer we get, we're going to FOIL into the third parenthesis. So this is x squared minus 4x plus 2x minus 8. This simplifies to x squared minus 2x minus 8. Okay, that's my answer of FOILing the first 2. Now I'm going to bring down the third one and rewrite it down here. So x plus 5. And then I'm going to FOIL these 2 parentheses. So I'm first going to distribute the x squared. Then I'm going to distribute the negative 2x. But since I have a third term there, I'm also going to distribute that negative 8. Okay, and I color code this so when I'm referring to it, you could see and follow along. So following the red lines, I have x cubed plus 5x squared. Then following the blue lines, I have negative 2x squared minus 10x. And then lastly, following the purple lines, I have negative 8x minus 40. Combining like terms, and then I get my answer of x cubed plus 3x squared minus 18x minus 40. Okay. Looking at this in general form, we see that the degree is 3 because 3 is our largest exponent attached to a variable. Okay, let's do number 7. Number 7, if you notice, this is factored, so we only need to distribute that x squared in order to put it in general form. So distributing the x squared, and I get x cubed plus 3x squared. And my degree is also going to be 3 because that is my highest exponent attached to a variable. Part 2, graphing polynomial functions to determine end behavior. So number 1, it gives us a function that is already factored. And then part A, it wants us to find the roots of this function. Remember, in order to find the roots, we have to first factor it, so it's already factored for us, and then set those factors equal to 0. So I have x plus 1 equals 0, x minus 2 equals 0, and x minus 4 equals 0. And then I solve for each, which means I get x equals to negative 1, x equal to negative positive 2, because I'm adding that 2 over, and x is equal to 4. Now that we found the roots, it wants us to write it in general form. So remember, since it's 3 parentheses, we're going to multiply the first 2 first using the FOIL method. So I have x squared minus 2x plus x minus 2, which simplifies to x squared minus x minus 2. And then I'm going to bring down the other parenthesis and write it next to it, so that x minus 4. And then I'm going to FOIL the 2, but I have 3 terms, so I have to make sure I FOIL all 3 terms. So first the x squared, then the negative x, then the negative 2. Okay. So following the red arrows first, I have x cubed minus 4x squared, then the blue arrows, negative x squared plus 4x, and then lastly the purple arrows, negative 2x plus 8. Combining like terms, I get x cubed minus 5x squared plus 2x plus 8. That is my answer. Okay. From here, I can find my degree by finding the largest exponent attached to a variable. In this case, it's going to be 3. And then it says, what is the sign of the leading coefficient? So the leading coefficient is always the number in front of the variable that has our degree. So in our case, we don't have anything there. So we assume that it's an imaginary 1. Well, it's looking for the sign of the leading coefficient, so we would write positive because 1 is positive. Okay. Then it wants us to sketch a graph, including the roots and any critical points, including the y-intercept. So we're going to first find the y-intercept by plugging in 0 for x. So I have 0 cubed minus 5 times 0 squared plus 2 times 0 plus 8. These first 3 terms cancel out, and I'm left with the y-intercept of 0, 8. Okay. So I'm going to be plotting the points negative 1, 2, 4, and 0, 8. Okay. So I have negative 1, 0, 8, which is a little off the graph up here, 2, and 4. Okay, let me zoom back in now. Okay, since my leading coefficient is positive, I'm going to start at the bottom when graphing this. Okay, and then before we graph this, we have to know that since our leading coefficient was a 3, we are graphing a cubic function. So y is equal to x cubed looks like that sideways s. So that is our goal of what our graph is going to look like. So I'm going to go up, I'm going to hit the y-intercept. I'm going to go down and then go back up. Okay, and then let me highlight this so you could see it a little better. Okay. From here it says, what happens to the graph as x approaches positive infinity? Well, our x's is this horizontal line here, and positive infinity is going to the right. So as this function is going to the right, looking at this endpoint here, we see that our function is going up towards positive infinity. So our answer is equal to infinity. Now it's saying what happens if x is approaching negative infinity. So as we go to the left, looking at this endpoint here, we see that it's going down towards negative infinity. Okay. Now let's scroll down here to number 2. Okay, so notice on number 2, it's already factored for us, and it wants to know what are the roots of this function. So we set each one equal to 0 and solve. So negative x squared equals 0 implies that x is equal to 0, and x plus 2 equals 0 implies that x is equal to negative 2. Okay. Off to the side, I'm going to write a little note. Okay, so if we have a polynomial with a double root, like x squared, then the graph is going to bounce off that number. Okay, and we're going to see that when we sketch the graph. Okay. Part B wants us to write it in general form, so we do that by distributing the negative x squared inside the parentheses, so we get negative x cubed minus 2x squared. Wants us to know the degree of the polynomial, and the degree is 3. And then it wants to know what the sign of the leading coefficient is. Well, that leading coefficient is a negative, so we know our sign is negative. Okay. Now it wants us to sketch a graph. Okay. So we're going to plot the points 0 and negative 2. So 0 and negative 2. And this time, since our leading coefficient is negative, we're going to start towards the top. Okay, so I'm going to go down. I'm going to go through this negative 2 point. I'm going to go back up and bounce off of that 0. Okay, that's what I mean by bounce. It's not going through the x-axis. It is touching that 0 and bouncing right back off to form our sideways S. Okay, highlight that so it's a little easier to see. Okay, part F says what happens to the graph as x approaches positive infinity. So as we go towards positive infinity, looking at the endpoint that corresponds to that, it's going down, so it's going to go towards negative infinity. What happens to the graph as x approaches negative infinity? So now we're going towards the left, looking at the endpoint that's at the top, it's going up, so it's going to go towards positive infinity. Okay. So what we just talked about was an odd degree, okay, because our degree was 3. 3 is an odd number. Now here at the bottom, we're going to just have a little note here that you can go back and refer to later. Okay, so if it's an odd degree but a positive leading coefficient, we know it starts at the bottom and then goes up. And then if it's opposite with a negative leading coefficient, it starts at the top and goes down. Okay, so the end behavior goes in opposite directions with the right side going up. And then on the other one, the end behavior goes in opposite directions, but the right is going down. Okay, so when I'm talking about in behaviors, I'm talking about these arrows. So notice how they're going in opposite directions, but the right side with the positive leading coefficient is going up, and the right side with the negative leading coefficient is going down. Okay, so now we're going to continue, but now instead of dealing with odd degrees, we're dealing with even degrees. Okay, so it gives us a equation and it says to factor. So if we have x to the fourth plus 3x cubed plus 2x squared, in order to factor this, we have to take out a GCF. Well, the GCF we can take out of all three is x squared. So if I take out an x squared, I'm left with x squared plus 3x plus 2. Notice that what I'm left with is something that can easily be factored by the AC method. So I do A times C, which is 1 times 2, and I get 2. So I need two numbers that multiply to 2, but add to our B value of 3. Those numbers are going to be 1 times 2 or 1 plus 2. So then I rewrite this as x squared plus x plus 2x plus 2. And then I divide this into two parentheses with the first two terms and then the last two terms. And then I take out a GCF from each. So I'm left with x squared. This first one I can take out an x and I'm left with x plus 1. And this next one I can take out a plus 2 and I'm left with x plus 1. Which means I have x squared, x plus 2, and x plus 1. Those are my factors. Okay. What are the roots or zeros of this function? So I do x squared equals 0, x plus 2 equals 0, x plus 1 equals 0. When I solve x squared equals 0, I get x is equal to 0. And then since this is a double root, I know that my answer is going to bounce off of x equals 0. Then I have x is equal to -2 and x is equal to -1. My degree of this polynomial is 4 because that's the highest exponent. And the sign of the leading coefficient is positive. Okay, now I have to sketch the graph. Okay, so now I'm going to sketch the graph. So I'm going to be plotting the points 0, -2, and -1. So here's 0, -2, -1. And then remember, I'm bouncing off of the 0. Okay. And also, since this is a polynomial with degree 4, we have to know that y equal to x to the fourth, when we look at that graph, it's going to look like a W. Okay, so that means when I'm graphing this one should also look like a W. Okay, so starting at the top, and I'm going down, and then I'm going back up, and then... Sorry, I don't know what happened with my pen. Okay, going down, going back up, and then bouncing off of that 0. Okay, notice how I didn't go through the x-axis on that. I just bounced off of it, and I still get my W shape. Okay, this one says, what is happening to the graph as x approaches positive infinity? So as it's going to the right, my endpoint here is going up, so that means it's approaching positive infinity. What is happening when it's approaching negative infinity? As x goes towards negative infinity, I look at the corresponding endpoint, which is going up, which means that it's also going to positive infinity. And this makes sense because our endpoints are going in the same direction, which means as x approaches infinity or negative infinity, they're both going to be the same number because they're going in the same direction. Okay, last example, number 5. So first, it gives us that we need to factor this out. So we have -x to the fourth plus 9x squared. The GCF I can take out of this is a -x squared. So I'm left with x squared minus 9. And since x squared minus 9 is a perfect square, I can factor this even more, and I get -x squared times x minus 3 times x plus 3. And this is only true when we have a perfect square that has a minus sign. Okay, so I take the square root of that c value, which is 9. Square root of 9 is 3, so I get x minus 3, x plus 3. This is my answer here. Now to find the roots, I set them each equal to 0. So x minus 3 equals 0, x plus 3 equals 0. So I get x is equal to 0, and I'm going to bounce off of that 0. X is equal to 3, and x is equal to negative 3. Okay. The degree of my polynomial is 4. And my sign of the leading coefficient is negative because it starts off with a negative x to the 4th. So I'm going to be plotting the point 0, 3, and negative 3. So 0, 3, and negative 3. And again, we know that y is equal to x to the 4th looks like a W shape. But now our leading coefficient is negative, so we have y is equal to negative x to the 4th, which is going to turn it upside down and now instead look like an M shape. Okay. And remember, I'm bouncing off the 0. So I'm going to go up, down to the 0, bounce off of it, go back up, and go through the positive 3. And notice how this looks like an M shape. Okay. So this one, as x approaches positive infinity, so to the right, I look at the endpoint and notice that it's going down. So this is equal to negative infinity. Same with the other side, as it's going to the left and approaching negative infinity, I notice that my endpoint is still going down, which means it's still approaching negative infinity. Okay, so now looking at our notes, we have an even degree with a positive leading coefficient and an even degree with a negative leading coefficient. So we know when it was positive, it looked like a W shape. And when it's negative, it looks like an M shape. Okay. So this tells us that the end behavior goes in the same direction. And then the right side goes up because it's a positive leading coefficient. And then the other side, the end behavior goes in the same direction, but now the right goes down. And again, end behavior are those arrows, so notice how they're going in the same direction, whether it's going up or down. And then our right side determines if it's a positive or negative leading coefficient. So since our right side is going up, this is a positive leading coefficient. And since our right side is going down, this means it's a negative leading coefficient.